Sure, definitely. Yeah. Hello, everyone. Uh, Welcome to the presentation on migrating RDBMS queries to Nickel. My name is Raju Suravarjjala. I work as the QE director for Couchbase, and here is Parag Agarwal. He is our senior software engineer for Couchbase, and we will be doing the presentation today. Let's go ahead and get started. Uh, the agenda that we will be covering is what are the motivations for migration, and what will be the factors in migration. Think about it like how do I move my data into Couchbase, how many buckets I should have, what should be my data model, what are the data types that are supported, and how do I migrate the data, how do I create the indexes and the keys, and how do I change my query statements from RDBMS to Couchbase, Nickel, and the CRUD operations that you will be working on. And we will try to summarize what all we have covered and wrap up with a demo. If you have any questions, please try to hold off till the end of the presentation so that we can make sure that the presentation is completed, and we'll try to answer your question as much as we can. So let's go ahead and dive into the motivation for migration into Couchbase. What does Couchbase do? It offers you the flexible schema. Unlike the RDBMS where you have the fixed schema and you need to worry about what are all the, SQL that you need to worry about. Here you don't need to worry about having any changes to your application at all. We do have support for JSON and binary data. We support up to 20 MB of binary data into Couchbase. Then the hierarchical data that you have, can be easily migrated into Couchbase. And Nickel offers you the extension to your SQL. We'll go through in detail what are all the operations that you can do on with our SQL++ or JSON plus SQL. It is highly scalable, so that's one thing that we want to make sure that you all are aware of. If you might have seen by now, it is MDS, it's multi-dimensional scaling, and it is very easy to add nodes and scale your query service, your data service and all, and it is highly available. So these are the reasons why would you would migrate your RDBMS into Couchbase. Parag?
Okay. Hello everyone, my name is Parag. What you are seeing here is basically a simple RDBMS database, sales database, and we have basically 3 tables: order, customer, item. We have the primary key defined for each table, and then there are foreign key relationships. And we are trying to do querying. We are trying to create indexes, then we are trying to do some complex queries with joins and subqueries like that. And our reference database is MySQL that we used, and we are going to see how we are going to take all this and migrate it to Couchbase. And as we are doing so, is there any issues? All right. So the first thing we need to understand is that what are the factors in migration. So when you migrate, there are certain things that we need to consider, like data model, data types, keys, indexes, SQL statements, and CRUD operations. The first thing we need to talk about is data model. Okay. So our reference database, like we've seen before, is this sales database with 3 tables, and we want to move this database to Couchbase, right? So Couchbase is made up of buckets, JSON documents, things like that. So the question we need to ask is, how do we actually translate all this into Couchbase? So we are going to say that we are going to map a database to a bucket, a set of buckets. We can map a table to a bucket, a set of buckets or key spaces. We are going to translate every row of a table into a JSON document. The schema for RDBMS is fixed, and we are going to move it to a flexible schema. So let's try to visualize this. The first example we are giving is because this is all normalized data, right? And so what we have done is we have mapped every table to a bucket, right? So for table order, we create a bucket order, and then we take every row of this. So we are going to take this row, and we are going to take the primary key of this, right? So this comes here. So we will make the key of the key value pair, and the value is the JSON document, right? So rest of the columns that you see here, customer ID, purchase date, item ID, we'll take them as field names, and their values will become their values. So that's how we translate, right? So this table has been mapped to a bucket, and the key value has been translated like this. The same thing happens for every table, right? So next thing we want to ask, next question we want to ask is this: is it possible, because we are mapping every table to a bucket, so is it possible to map a database to a bucket? So we know that JSON can be hierarchical, nested in nature. So we are going to use this factor. So what we do here is that we are going to add one level of hierarchy, right? So as you can see, the order name of the table here, we added one level hierarchy, right? So this was the key, right? So this previously was this document. So what we do is we add one level. So we have name. Name is the name of the table, and the rest of the value is the JSON document. So by doing so, we have created a bucket sales, which is the sales bucket in RDBMS, and then per key value pair we have done this. So we have mapped a database to a bucket. So next we would like to know if we can map a set of databases to a bucket. All right, so this is also possible. Like I said, JSON has nested hierarchical nature, is quite flexible also. So we now add another level of hierarchy, right? So say we have a default bucket, right? And it contains several databases. Per key value pair, what we have done is, we have again like, for this table, right? We again have key O1, and for this is the value of the JSON document. And for the first level, we have the name as the name of the database. Then the value is again you see it's a child JSON, and within it again you have name value, and order is the name of the table, and this is again our original value, the original JSON document. So by introducing two levels of hierarchy, we are able to map databases to a single bucket, and this is all for this normalized data. Now this example shows you that we are trying, so this table itself, right, for initially must have been a big huge table, right? Then we normalized it and we defined the keys relationship, things like that. So we can also push this in a denormalized way, right? So this example show you, right? So we have again the key here for this table, and then we at first level we have sales, then second level we have order, and within order you have order information and the customer information and item. So that's how we actually map a set of databases to a bucket even in a denormalized way. So what the examples you have seen, what we are doing is we are basically pushing all the normalized data in a normalized way, or normalized data in a denormalized way. And we can map tables to bucket, a database to a bucket, that set of databases to a bucket. Okay, so next topic we are going to talk about is data type. So we pushed every table to a bucket. So the next thing we need to consider is, since a table consists of columns and it has data types, each has data types, what happens next? So this matrix basically tells you the story in short. So we have data feature type here, what happens in RDBMS, what happens in Couchbase. So when you talk about case sensitivity, it can be present or not present. In case of Couchbase, what we need to consider is that since the data is JSON, the fields only are basically case sensitive, otherwise it is not. When you talk about numbers, strings, both are the same, so there is no big difference. When you talk about Boolean, when you talk about MySQL, they are generally stored as tiny int. And in case of Couchbase, JSON is true and false. Datetime is supported as a datetime format in RDBMS MySQL. In case of Couchbase, it is stored as a string. So what Nickel provides is a set of functions where you can use this function to convert them into numbers. So next few slides we will visit this topic again. Spatial data is supported in both. There is a new data type missing. It is not supported in RDBMS. It is specifically to JSON, and in the next slide I'll visit this. Null is the same as MySQL and Couchbase. Objects and arrays are not supported. In MySQL it is supported in Couchbase. These are specifically to JSON. Objects means an object of JSON, and array is again like an array of objects, things like that. Blobs are supported in both. So we are going to talk quickly about missing. So what is missing doing? So JSON has, as you can see, it has name, value, right? So which we can say this is a field, right? So if you have key value pairs like that, we want to find in which particular JSON document a given field is missing or it is not missing. So that is the purpose of this, right? It gives you the ability to search for documents where key field name is missing or not missing. So if we are to take this example, select star from customer where name is missing, we will try to get those documents where name field is missing. So in this case, here as you can see, in this case it is present, here it is not present. So this should be the output. So what is the impact of missing, right? So we know that we have null, which is also present in RDBMS from MySQL, and true and false, right? Now a new data type has come into picture, right? So obviously when you're doing operations like A or B, A and B, things like that, so their outcome is going to be different because we have one new element. So there is a four value logic. Same thing happens when you're doing not. So we saw that we can take the fixed schema in the data modeling. We saw that how a fixed schema can be translated into a flexible schema and dynamic schema of JSON in Couchbase. We saw that data types, it's not very difficult because everything is quite similar. The next thing we need to consider is keys and indexing. So first let's talk about the primary key. So like in the previous slide we already saw that we are basically taking every row of a table and translating into key value pair where the primary key is translated here. So this has to be unique in nature, right? So and this is string. So and this for every bucket obviously you have unique primary keys. So this is what is happening here. One thing we need to consider is that so in databases this whole row can be identified by the surrogate key, and some databases expose and some don't. In case of Couchbase, what you can observe is that this key is same as the primary key, and there is a function which is not mentioned here. It's called the meta. If you search in the documentation, you will find it that can expose this primary key. Okay, so let's talk about foreign key. So this database has a foreign key relationship. So order table has a customer ID foreign key into a customer table with a primary key. See C1 here are the same. So how do we actually identify these relationships here? So what we do is we know the primary key. So we have basically marked this here and we call it the secondary keys. Now that we have identified what keys we want to build indexes on them. So next topic is indexing. So indexing prior to 4.0 beta was supported in views. Now we have a new indexing service. It's called global secondary indexing. It's abbreviated by GSI. Now it has, both of them have support for primary index and secondary index. If we are going to give hints for views or GSI based indexes, they are same, and the syntax is very similar to MySQL. Primary indexes. So here I've given a set of examples where you're creating index, where index has alias here, or you're trying to drop index. One thing you need to observe is that when you're trying to do is, we have to qualify it by the type of service you're using. So it says using GSI or using view. The default, if you don't mention this, the default is view, right? The same thing is for drop. So for primary indexes, one thing we need to observe here is that since there are two services that are providing indexing, at the same time simultaneously you can have primary index on views and JSI. So that's why when you drop, you again have to qualify which service are we using. Okay, so secondary indexes. So we have support for simple composite. Uh, Now simple is having one field as shown in the example. So what we need to observe here is that since the nature of JSON is flexible, it basically means not all documents will contain a field, right? So for example, if you are saying create index on customer, a field name is mentioned. This is the column name, right? If you run this in MySQL and this particular column name was not present, right? So this will error out, right? But in case of in Couchbase, this will not error out because field may or may not be present, or in future it will come. Who knows, right? So this will never error out. Composite example index, we are using two field names here. Now we are going to talk about quickly about where conditions. So what happens is that a given index, for example, on a name for a customer can be really big, right? So we want to use the concept of partitioning. The way we do partitioning is that we add a where clause here, right? Where name like a percentage using JSI, right? So we can actually break them in alphabetical way. So when we are trying to basically give a SQL and you can say use index, use this particular index, right? So we can actually use a particular index in a sorted way. Computed index, what this basically means is that suppose we are here basically using the field, right? And whatever is the value of the field, we are using it. But we want to change the value in which we are storing, right? We're creating the index, right? So we can actually compute these, right? So here what we are doing is we are taking the first name, last name, and we are going to concatenate. This is how the index is built. So when the SQL is going to run, it is going to identify in the where clause the way the conditions are defined, it will match to this and pick this index and will start using it. So that's the advantage of computed index. And this is the example for drop index. Okay, so we moved from data models to data types. We saw about what's happening in keys and indexes. So let's talk about an important topic, SQL statements. The first thing we need to understand is that the nature of JSON is flexible. We need to know that it's hierarchical. We know the data is nested. So this example is nested feature, right? This is how a nested structure looks. We have the name of the database. We have the order, which is the key space or the table name, and then within it we have customer item, right? So we need to ask this question that if I wanted to say in the customer, I want to get information about name, how do I do it, right? So this is how NQL solves this problem. So you select c.name from, then you do sales.order. So there is a nested operator dot here, right? So that's how you are getting sales here maps here, order maps here, customer maps here, right? Then you take a alias c and c.name will get you the information. Then the second example, say you want in the item, there is a field store ID, then it maps to a values array 11, 22, 33, right? And you want the first element here. So this is how you will give. So you can get an array element like this. Or if you wanted all fields of customer, this is how you get. So you write a simple query like this and it will actually extract all the information and put it out there. So you are able to actually traverse through the nested data, and using the nested operator we can extract all the information. So that's the power of NQL. You're actually able to extract all the information. So we were talking about existing data, right, where you have name and value, things like this, they exist. So let's now talk about non-existing name and value things. So first we'll talk about name, non-existing field, which is the name here, basically. So what this is telling you is that, like I said, the nature of JSON is, what we have is a flexible schema. That basically means that sometimes a given field right here may be or may not be present in the JSON, right? So when we run this, it will not break, it will not error out. Instead, if we run this SQL, it will basically, since field is not present here, it will return an empty set, right? But in case of RDBMS, this would actually break. So that's the difference. We already visited this is missing. It's basically used to see if a field is present or not, right? So this particular thing, right? So name is missing. Yeah, it is missing. So obviously when you run this query, you will get this result set. So we talked about the name. Now let's see how do we counter the case where value is not present. So in case of non-existing values, there are two things to consider here. One is valued. So if this is empty here, right? So you need to find out all those JSON documents where this is empty. So there is this operator is valued. So you can use this and find a set of documents like this. Then is null is very similar to what is present in MySQL. If this is null, then you can actually find it. So so we have is not valued or is not null in a very similar fashion running. Okay. So let's move on to a very important topic, joins. So we have left, outer, and inner joins. So for example, the example I'm taking right now is our reference database, sales, order, customer, item, and we are going to do a query, right? So we are going to do a select star from order O, inner join, customer C, on, and then we are going to take the outer table key, foreign key here, I'm going to map to the primary key of here, right? And again another inner join like this. So how do I actually translate this into NQL, right? So we had in our, when we were moving our moving from fixed schema to a flexible schema, we had defined these key value pairs, right? And then we did, for NQL, we will write this query like this. Select star from sales.order. So the previous slide, we have seen how to get using nested operator the tables when there was like a nesting going on. So this is basically sales.order. This is the bucket name. Then order is basically one level down. And then we say inner join sales.customer. And instead of saying on followed by comparison here, we say on keys. And this thing is basically the outer key space, right? So the outer key space, and it will mention the field name that we need to match. And what this essentially is going to do is, it is telling NQL, go and match with the primary key of the inner key space, right? Inner key says is sales.customer. The same thing happens here. So you see that there is a format difference here and there, and you have to translate your query this into this for it to work. So when you are trying to run this query, basically we are going to get a nested output like this. We have order, customer, item. Now there is a concept of nesting in in NQL. That essentially is that, say for example, in an order you wanted an array of all items like this, right? But if you run this query, you are not going to get this, right? So we are going to change the query a little bit and basically say that select sales.order.star, then you want to get the item from sales order, then say nest, right? So in nest is basically an inner join is happening, that is optional, so it's not mentioned. And we do this, and magically you will basically get an array of such items. So now that we have seen that output is nest, then we can make it more interesting by giving an array of items. How do we actually remove nesting? So it's a concept of unnest, right? And what it does is primarily, let's see this example here. Say we have this key value pairs, and from order I want to extract purchase date. From customer I want to extract name. From item I want to extract description, right? And I want to extract all of these and put it into a JSON document. So how do I do it? So we will define the NQL like this. This coming here. Then say unnest, and it will basically take this information from here, unnest, take this information from here. And when we do this, it magically basically gives you all this information in a single JSON document. So that's the beauty of NQL, right? You can do nest, you can do more interesting nest with array of items, or you can remove the nesting. So you can actually translate your information. Okay, use keys. So if we were to write a simple query like select star from customer, and we had a primary key index on this, so what's going to happen is that it's going to open the primary index and do a full scan. Now full scan is inefficient. So how do I make this efficient? So use this use keys, and you mention the key name, or you give this as an array and mention the key name. So where can this be used? So here's the example, the application of this idea. So we have a query, this is a parent query, and there is a subquery here, right? So if this was very slow, this will take a long time to get result and do the comparisons and get the response back. So we can use keys and say that use this particular key. So this becomes really, really fast. The same thing is happening here in the join example. Okay. So in the data types, we had mentioned that your date time is basically stored as strings. So that would basically mean that if you write this SQL, select star from order where purchase date greater than this. If you write this in nickel, this comparison is not right because they are strings. So we have provided methods, functions that can actually convert this into value. So this is going to convert this into milliseconds. The second example shows the same thing where we have now and we are going to convert it. So even though JSON actually supports in string format, the good news is that we have functions that actually can translate this query into this, and then they will be backward compatible. All right. So we just went through SQL statement and saw what the difference is. We can do joins, we can do nesting, unnesting. We have primary scan efficiency using use keys. We have then support for date time operations also. So next thing we are going to cover is CRUD operations. So insert. So we know that data inside Couchbase goes as key value. So there is going to be a format difference between SQL and nickel. So I always have key value. There is a new feature called returning star, or it can be an expression. So what this really helps is that whatever you insert, you can get the data back and you can validate whether the data was inserted. You don't have to write a separate statement and validate. So that's how it is different. So there is going to be a format difference with a new feature, and that helps you. And there is a new implementation called upsert. What upsert basically does is that if you have a key value and if it is present, I'm going to update it with this value. If this key was present, I'm going to update it. If it is not, I'm going to insert. Now MySQL has a special implementation for this. There's a workaround. So I would not call it special. There's a workaround for this. Meanwhile, we have a special implementation. So this, if you see insert and upsert, they have the same format except that there is just a little bit difference. Upsert, insert. It will just change the keywords. When you talk about update, delete, they are backward compatible, can have the same format. They can be different when we are trying to use keys. When you do primary scan efficiency, or you are trying to do returning, which helps in validating values. When you're updating or you're deleting, we need to validate whether the operation went fine or not. So that's how it can be different. Okay, so I'll summarize everything I just talked about. So we went on data model where we moved a fixed schema to flexible schema. We are able to map tables to bucket, or database to a bucket, or a set of buckets to a set of databases to a bucket. We do it for both for normalized and denormalized data. For data type, they are quite backward compatible. We have new data types like missing, arrays, and objects. And we saw these help specifically for JSON data set. We have for key and indexes, they are backward compatible. The good news is that now we have two services, views and JSI. For SQL statements, we can do joins, we can do nest, unnest. We have date time functions, we have new operators for new data types because JSON has new extra data types. And then for CRUD operations, we saw that insert, delete, update are almost the same, except that insert is a little different because we store data in key value format. Then there's a new operation, upsert. Okay, so now we will go through a demo which Raju will present.
All right, so what am I going to cover here? I'm going to move the data from MySQL. It's the ubiquitous world database that you already must be familiar with. And I'm going to move that data into Couchbase. And I'll use a tool called Talent, which can be used to migrate data from your any database that you want. But in my case, I will be using MySQL. And then I will try to create the primary indexes and cover as much as what Parag has talked through. and we will try to run some queries, and I will also explain the queries. So let me just try to go to the talent tool. Okay, so what do I have here? I have defined the input from MySQL, and if you want to see the schema in MySQL, we can see that I have 5 columns: ID, name, country code, and district and population right there. So what I'm going to do is I'm going to move that to Couchbase. So for that, remember I need to first create the bucket into Couchbase. So let me go to the console. I log in first. Okay, I will create a bucket called city. Okay, the bucket is empty. If you go to the documents, there are no documents. But let me go to my MySQL database. Hopefully you all can see it. So let me see how many rows are there. Okay. All right, so I see 4079 rows. Okay, so once the extraction and the transformation happens, I should see the same thing in MySQL, which is in the Couchbase, which is here is how I have defined. The root element is ID, and name, country code, district, and population will be migrated. Okay, let me see whether this demo works or not. Let's run it. So you can see that each data is being moved into Couchbase, and now if we go into our data buckets and see city, you can see the total item count as 4079, which is exactly the same as what you had in MySQL. So you can browse through the documents and all. So now we moved the data from MySQL into Couchbase. I'm an application developer, and I have some queries I want to run, and how do I do that? Okay, let's try to do that now. I have 2 options. One is to use the MySQL client, and the other one is the CBQ, which is the query engine for Nickel, and try to run the queries. Okay, let's try to do that. Before I run any queries in Couchbase, I need to define the primary index. So let me just create the primary index here. Okay, I'm into CBQ engine, and I'm creating the index. So once that is done, I should be able to query the same way as I have done in MySQL versus into Couchbase. Okay, all right. So what I'm doing now is I'm doing a select star from city. Okay, all right, fine. Let's try to do that first in Couchbase. So here, for this, you don't need to create any indexes and all. Sorry. Make it bigger? Font, okay. Thank you. Is it better? Is it better now? Okay. All right. So, okay. And now if I go to the MySQL client, also it should show me the same information. All right, where are my terminals? I have too many windows open, guys. Okay, better. All right, now I can do the same thing from it from something called Tableau or something, okay, and I should be able to get the same information back. Let me first show the uh, running the queries also with. So here I got the JSON back. You can see the country code, district ID, name and population, and when I go to MySQL client also I should see the same thing. Where is my MySQL client? See, you can quickly see that the data that I saw in Couchbase is exactly the same as what I see in MySQL. Okay, so I have written my application and I didn't have to change too much code at all. All I had to do is define my primary indexes, and I'm in business. Now let's talk about the flexible schema. So what happens when I run something like this in if my application would have done something like this, okay, where I don't have the primary the column name present, so it will give you an error in okay, where is my window? So you will get the right error back from MySQL because it doesn't know, and your application would have got an error. But what happens if we go to Couchbase? See, you don't get any error, but there is no result set at all. So you see the difference, and let's try to now do an explain statement, and I will wrap it up. Uh, See here you can see that it's doing a primary scan, and the index is primary, and the key space is a city, and the namespace is default. So this is how Nickel has done the queries for you. If you are not interested in JSON data back and you are interested in seeing the data back into the way you are used to, you can use something like Excel. Let me bring it up. So what I'm going to do now is I'm going to use the Simba ODBC drivers, which is already set up for me. So this is the database driver that I have. Okay, it is set up correctly. All right, it's configured correctly. I will say I'll go here and I will use the SQL view, and I can run the queries that I want to run. See, you got the data back the way that you are used to from MySQL. With that, I wrap up and I ask you if you have any questions for me or to Parag. Yeah, go ahead. Can you say that? It's called Talent, TALE, Talent Studio for Big Data. Oh yeah, the question is which tool has been used to migrate the data from MySQL to Couchbase, and the tool is Talent Big Data Studio, the studio for big data, and I have a link for that too. If you are interested, I can give it to you. Yeah, go ahead. Okay, the question is that what is the best way to migrate the data if you have nested objects and all? Yeah, correct. Yeah. Yes, yeah, we do. Actually, the question again is, what are the best practices that you should use when you are migrating the data from anywhere into Couchbase and all? Yes, we do have the best practices. The maximum number of buckets that you can have is up to 10, and about the data elements and all, it's up to you, and we can go into details of what is the best way depending upon the application that you want to write and all. But we can figure out a white papers or something like that that can help you out with it. Okay. Are there any other questions?
Okay, thank you.
Okay, thank you guys.